Good day, students and viewers. Okay, so today, this will be the part 2 of our topic under kinetics. We have the force and acceleration. In part 1, we have discussed about um, basics of force and acceleration under kinetics, in which unlike statics, okay, so if we say statics, it is not moving, okay, so we have the summation of forces is equal to 0, while in kinetics, since it is moving, so in other words, there will be an acceleration, okay, so as stated in the second law of motion, okay, stated in the second law of motion, in which your force is directly proportional to your acceleration. And if there is a movement and there is a displacement, there is an acceleration, therefore, your kinetics, in kinetics, we sum up moments is equal to mass times acceleration. But somehow, these formulas, we need to have proper discretion in order to identify whether in X or Y axis you should apply if your force relative to that axis is equal to 0, or is it equal to mass times acceleration. Okay, so let us go back. So let us go back to the block. Okay, so maybe we'll go back to our discussions about block. Okay, so there are two. Okay, sorry. Okay, so we all know the types of forces. So if you can remember, in part 1, so we have normally this will experience its own weight. Okay, it has a force, it will experience a force which is its own weight. All of us have weight, so it is equal to mass times the acceleration due to gravity. And then, since, okay, there are always two forces acting, okay, acting upon the ground in which any object um, is upon. Okay, so it could be the normal force and the friction force. Okay, and then there is a direct relationship between this friction force and this normal force, in which your friction force is equivalent to mu times n. And this mu could be mu s, okay? Mu is, or the coefficient of friction is equal to mu s when at rest. Okay, so this is just a review on our first video. Okay, but this time we will explain whether we will use summation of forces equal to 0 or summation of forces is equal to mass acceleration. And then it could be your mu or your coefficient of friction. Okay, remember this is coefficient of friction is equal to mu k when in motion. So it will have two different values. Okay, so that is n friction. And remember, your normal force is always perpendicular to the surface of motion. Okay, so this is your surface of motion. So this normal force is perpendicular, and then it always resists the weight. Okay, but sometimes your weight is always vertical, but somehow your normal force is not always vertical. Okay, so it could be be this situation, okay? So let's repeat. Okay, let us repeat, okay? Let us redraw, okay, the past lesson. So if you have weight here, your normal force should be always equal to, okay, should be always perpendicular to the surface, okay? And then your friction force, it depends upon the situation. So if um, your block is moving towards that direction, your friction force will be always the opposite. If you go upward, so your friction will be, okay, in that direction also, okay? So that is the case, okay? So let us say in this drawing, we have your force here, okay? So if you remember that if this force is greater than your friction force, it will move. But if this force is not enough to move this block, it will stay in its original position. So therefore, okay, so in this drawing, okay, so how do we apply whether we use this, okay, so whether we use summation of force is equal to 0 or summation of forces equals to mass times acceleration, okay? So we look upon this drawing. So your force or your force that you attempt to apply in order to move this block is this, okay? So therefore, in this direction, we can say, okay, so let us say this is your x and your y-axis, okay? So therefore, summation of forces along x is equal to mass times acceleration x at x, okay? So this will be your equation along x direction. But somehow for your y direction, okay, so basically this is your force, it only moves horizontally. So therefore, there is mass times acceleration to the x direction. But somehow, relative to the y-axis, it is not moving. So therefore, we will use for y-axis as summation of forces at y is equal to 0. Okay? So meaning, it is possible that in x direction, it is dynamics. Okay, you use second law of motion because it's dynamics. Here, okay, since it is not moving relative to y-axis, so you sum up forces equal to 0. So you use the concept of first law, in which inertia, the law of inertia. Okay, so I hope you understand. So it's not always the case that your sum up forces, it will be always equal to mass times acceleration. Okay, so let us say you are pulling up forces here. Okay, so in order to move in that direction. Okay, okay, so this is another impending block. Okay, so I just want to know, you to know that if this block is theta, okay, has theta degrees relative to the horizontal, so therefore this weight, because your weight is always, okay, please remember that your weight, the weight is always vertically downward. Okay, so it always acts like this. Okay, it doesn't matter what is your position or what is the position of your particle, it will be always down. Okay, so that is the case of weight. It is always downward direction. It never it never be like this that has a degree. Okay, degree with horizontal or vertical. So your W will be always 90 degrees, okay, relative to the horizontal. It is always vertically downward. So okay, so for all our problems, if this is theta degrees, this will be also theta degrees. In degrees, this should be equal. Okay, so in order to lessen up your difficulties, if you see that it is given that this platform makes theta degrees with the horizontal, so therefore the weight of your object is theta degrees relative, okay, relative to, okay, perpendicular perpendicular line relative to that surface. Okay, so in order to lessen up your difficulty here, you can put your x and y axis into such a way that your x axis is parallel to your surface and your y axis is perpendicular to your surface. Okay, so you can also use x and y like this, but somehow there will be a lot of forces involved because you have to convert all of these forces into x and y axis, which is horizontal and vertical. So it is easier if you use this one. So that's okay. So how do we know? Okay, in x direction, obviously, okay, this is our x direction. Okay, so this is our x axis here, which is parallel to this surface. So therefore it is equivalent to mass times acceleration x. So you use this formula. But somehow in y direction, since it is not moving relative to y axis, your y axis is perpendicular to the this platform or this surface. So therefore your sum of forces along y is equal to mass times acceleration. Is equivalent to 0 since it is not moving relative to y-axis. It only has mass times acceleration x in the x-axis since it is moving in x direction. Okay? So, but what if you use this type? Okay? So, if you use this type, obviously, both x and y axis will have mass times acceleration x and mass times acceleration to y axis. Okay, if you use this, but this, if you use this system of x and y axis, obviously you will get 0 at y axis and only your x axis will be equivalent to mass times acceleration. Okay, so there are certain problems that you cannot solve or it's hard to solve using this in which your x-axis is the horizontal and your y-axis is the vertical. Okay, so that is how you form your equilibrium equations along x and y-axis. Okay. Okay. So maybe we